Is everybody hearing me?
Yeah, oh yeah, you're good, Lance.
Okay, good.
Yep.
Glad to hear that.
Say it a little bit louder for the rest of us in the back of the room.
Is everybody hearing me?
Ooh.
You merely adopted the dark.
If I ever want to do a podcast trailer, I know who I'm coming to.
Right?
Yeah, that new setup's treating you well, Lance.
Thank you. Yeah. In a world without security.
Well, that's the world we live in, dude.
It is. It is. we got a little.
Yeah. It's okay. I'll just put it on a different port. They won't find it.
Till somebody drops it on Shodan and you're like, oh.
What do you mean capital A SDF 1234 bang isn't a secure password? It ticks all the boxes. It's got all the requirements in there. Welcome to OT After Hours, podcast about industrial cybersecurity, why it matters, and all of the challenges that it presents. And this is the first podcast episode too, the pilot episode, the inaugural episode, the let's figure out if we even know what we're doing episode. I don't know. Let's see if we. Yeah, well, yeah. This is where this is where all the bugs come out, and then we'll patch them in future releases,
of course,
and introduce new bugs.
It's not a bug, it's a feature.
Well, before we dive into the topic, we should probably go around and introduce ourselves. This being the pilot episode, it's still too early to say whether any of us will become regulars on the podcast, but I'm going to go just from left to right across my screen. We have with us today Lance Lamont and Tyler Bergman and Dylan Stencil. And why don't each of you, starting with you, Lance, why don't you just take a minute to introduce yourself and tell us a little bit about who you are, what you do?
Absolutely. Foremost, I think I'm a creator, explorer. I love taking on new challenges, whether it be hardware, software, anything of the sort. With Verve Industrial Protection here, I am leading the research team where we take on various OT devices and try to understand how to communicate with them to work and gather as much information on the devices as possible. For this discussion, I think I'll be talking about some of the adventuresome little things we found related to the security of devices. That's it.
Brilliant. And how about you, Tyler?
I don't know if I want to date myself that bad, but here we go, right? So yeah, Tyler Bergman, I've been, doing utilities for the last 20 plus years, from a distribution cooperative to a local municipality, and did a lot of various things as well. Started at a very young age tender age of 9, working on my TRS-80 computer that I have very fond memories of, writing in basic code back in the days, and that kind of fell forward, and now I'm here with you guys talking about OT security.
Nice.
All right. So my name's Dylan Stencil, part of the research team under Lance Lamont, and kind of had a interesting start in the industry. I kind of grew up with it. My dad owned a CNC shop, and basically I've been interested in technology since a young age, and I've started with doing pretty much controls work hands-on, and then moved kind of through the years into the security space now that it's becoming ever more important. And it's just a little bit about me.
Brilliant. And I'm Kenneth Kully, cyber team lead with Verve. And then before that, I've worked for a few other companies. Pretty much, it's kind of funny because even when I think back to being an engineering student and grabbing summer jobs with whichever engineering firms were hiring through the U of A jobs board, I kind of always ended up in the OT space, whether that was doing, lightweight SCADA programming for oil and gas companies or pipeline companies, or, working with industrial cybersecurity groups at different companies. And so, yeah, I've kind of just always been in the orbit of OT, but it's really only been since about 2008 that I've kind of formally gotten into the industrial cybersecurity track, and have kind of been with it at a number of companies ever since, Verve being where I've ended up. And in a lot of respects, Verve is kind of like the culmination of all of that other stuff, because it was always about like information and getting information on systems and like figuring out what do we even have in the environment. And like Verve literally has the whole solution already built that I was trying to build at my previous employer for like the last 5 years. So it was an easy transition to make. So as the pilot episode for the podcast, I wanted to explore something related to, like I said in the intro, why it matters. And not just in like a generalized sense. Hopefully we all know that we shouldn't, reuse passwords or use 1, 2, 3, 4, 5, 6 as a password. Most of us probably have experience with ID departments and maybe malware infections. So maybe we kind of understand why the internet-facing stuff, at least, needs security. I realize that I'm making a lot of assumptions there, but, my hope is that, if you're specifically going out of your way to look for an OT security podcast, an industrial cybersecurity podcast, these are concepts that are probably not strange to you. But it is a little bit different in OT, isn't it? Which ideally is not supposed to be internet facing. OT is supposed to be the stuff on the plant floor, hooked up to that paper machine or the boiler over there, ensuring that, whatever process is important to a facility keeps processing along. And I mean, yeah, we're going to actually have to do a whole other episode on what OT even is. But Lance, you actually pitched the idea that I thought would make a good topic for this first episode. And it really kind of gets more towards the question of why industrial cybersecurity even matters, because a lot of the connected devices that exist in OT environments do have vulnerabilities, not always ones that have been published, let alone patched. But it can be difficult sometimes to really communicate to people who work in those OT environments just why it's important to worry about that.
Yeah, absolutely. The OT environment, will definitely have to dive into that future podcast, or you will at least, has some really unique requirements, right? We want to make sure our systems are up and running all the time. We need to make sure the manufacturing plant is working. So it's a much harder environment to make sure it stays up to date. And it actually can be risky to update things in the OT environment. The case of, I believe it was a Windows patch port, which meant it took months to get the systems back up and running after that patch was installed. So there's lots of cases where there's a strong drive to not make changes, not make any updates to an OT environment. But from our experience, and we've got lots of experience on this podcast today, there are many, many scenarios where that the obvious risk of updating is much, much smaller than the risk of not updating from a security standpoint. So I thought we could start out a little bit here and talk about some of the interesting public OT security incidents. I think almost everybody's familiar, or of our listeners will be familiar with Stuxnet. So does anybody want to give a little refresher on what that was and talk a little bit about how it happened?
It's probably worth diving into, just because, we think of it as recent, but we're old. And some people are coming to this industry who, maybe were, even in high school when Stuxnet was a thing, and it might have escaped their notice at the time.
So, Stuxnet, it was like the first case of kind of an industrial espionage, and I think it was against Iran for their the centrifuges that was going on over there. So it was basically like a piece of like a malware that was delivered on a dropped USB into the system to try to really grenade these the systems that were trying to do the enrichment process for these centrifuges and all that. So it was pretty simple. So that was kind of one of the first case in an instance of, the industrial espionage, and it's more nation state type of things of that nature going on at the time. And I'm sure those of you guys out there that are readers and things of that nature can go out there and read the book Sandworm. It goes into great detail and lengths of, how all of that really kind of happened and some of the technical aspect around it. Very interesting read, especially if you're just getting into like the OT cybersecurity side of aspect in it. And it's almost kind of I don't know. What do you guys think? Is it more of kind of the initial foray of like an industrial incident type of thing where it was a malware type casement and things of that nature?
Well, it's actually probably one of the first cases of OT device attacks. It originated with targeting a specific controller that was used in their facilities, and that's really never been seen before. I believe it dealt with just manipulating the process values of the controller, and I believe that's through some firmware vulnerabilities that they found. Regardless if the countries in question worked with the manufacturer on that or not, that's to be determined. But regardless, regardless, we've started to see an uptick in those type of issues. While it's not the most common attack threat vector, it's definitely one that we've had to be more aware of in the coming years, especially with internet connected devices and systems.
Yeah. One of the things I find particularly interesting about this one is, if I remember correctly, their devices were not directly internet connected. And so they dropped a USB stick, somebody put it in one of the computers on their network, and it managed to infect the OT devices through that. So even when we're talking about the context of OT devices in a internet connected scenario, we have to keep in mind that these vulnerabilities, or the things we're talking about, can happen even on an entirely disconnected network if one person doesn't follow reasonable security protocols, and if the network itself is not architected in a way to protect the devices within the network. So there's a lot of additional context past just, hey, okay, I'm not connected to the internet, I'm fine. We have to think beyond a little bit of that. But Stuxnet is a great example of some of the things that can be done. And there's lots more that we could be talking about. There's just tons and tons of reasonable examples on this. We should bring a few up if we want, but it's been interesting because a lot of the devices we've explored here when we're doing research end up having vulnerabilities that we don't even find any public disclosure on it at all. And some of these are really, really fascinating. We found one device that if we sent a specific packet to it would literally erase itself and reset. So if you were to be able to send that packet to that device, you would be down until you could recreate the information on that device. So it could take a long time. But anybody else have any interesting examples of other vulnerabilities that we'd like to bring up?
Well, just not so much a vulnerability. I mean, it is a vulnerability in a sense. It is a vulnerability in a sense, but I think, you've teased out something really important, which is that, and this is something that, I continue to see in engagements with our clients. It's something that I definitely remember encountering during engagements with clients at previous employers, because when you're getting onto that OT network, and, what is the core of our software, right? Like, we're trying to do device inventory. We are trying to find what is out there on a network environment, specifically an OT network environment. And there's kind of an attendant nervousness that a lot of clients have when it comes to doing something like that, because a lot of the devices that they have out in the field, out in play, hooked up to their processes are, shall we say, not the most sophisticated, not in the sense that, they don't do sophisticated things to monitor and control the process, but the back-end implementation through which all of that happens might not be as robust as we would expect. If I have a Cisco switch deployed in a network environment, I can be reasonably sure that I can subject it to just about any network traffic imaginable, and it has a fully implemented network stack, and it can handle it. If I send it bad packets, it can handle it. If I send it malformed traffic, it can handle it. But I can't make that same assumption about that PLC over there. It probably, the reasonable assumption when you encounter some of these critical devices in OT environments, PLCs and controllers and things like that, is that they probably don't have a fully implemented network stack. They probably only have just enough to handle the traffic that they're expecting to handle and to send the traffic that they're expecting to send. And if you send or request anything weird, there's a very good chance that you will tip them over, or like you pointed out in the case of whichever device that was, oh, shoot, I sent some malformed traffic to it, and now I've just erased all my device firmware. Did I have a backup of that? Geez, I don't know.
Exactly.
Right? And that's the real problem with OT environments, is that just the sensitivity of the devices.
Right. The secure by design concept type of thing, right?
Yeah, it's very absent.
So I got another prime example of that as well. So the example was given was there's this robotic controller out there that if you send it a single ping, it automatically sends the robot into the home position. So for those of you uninitiated as far as, robots in the home position, so there's like different knuckles on the robot, and there are...
You're talking like the sort of things that would be on like a vehicle assembly line, right? All the articulating joints and...
Right. So robot control arm basically has multiple different articulation points, so like an elbow, wrist, fingers, things of that nature. And by homing a robot, it goes to a known position. So that way, like say if it gets kind of out of step for one of the articulation points, you can like hit a button on the robot and it'll unlock the joints, so you can match it up with the hash marks for all the particular joints. So that's basically sending it home to, what its known state is for what it's calling like zero reference for all the joints on it, right? So just by sending a single ping out to this robot controller, it sends this robot into this home position, which may or may not be a good route for the robot to go, depending on where it's at in this process and things of that nature. But I was just thinking in the back of my head, it's like, because there's, multiple times, I think in the cases of ours where, we're trying to do like either ARP sweeps, ping sweeps, port discovery out there, things of that nature, and trying to be, not nefarious about it in that type of way, but we're trying to figure out what are some of the systems and aspects out there for inventory and things of that nature. So we got to resort to the methods that we have. Ping's one of them, and it's utilized across the board in IT space. OT space is not really seen as much because of, those types of specific examples that are out there. And there's still to this day, you walk into an OT landscape and there's like, well, are you going to do port sweeps across the board here? It's like, well, no, not exactly. Not the ones that you're used to.
Nope.
No, we're not going to go in there and hit all 65,000 ports for all these devices out there. There's a couple of very minuscule ports that we are looking for just for the specific devices that are out there. But yeah, definitely not the whole range of 65,000 ports. It's just super intrusive. Devices can't handle it, especially in the OT landscape. So yeah, but yes, that's just my example of just kind of the weirdness of some things that I've read out there. And it's just like, wow, who does that?
Which, goes to show that this is, I think, one of the reasons why, having a robust industrial cybersecurity program is kind of important, because Stuxnet is kind of an outlier in some respects, right? Like, it's an interesting example to point to, but it's kind of an outlier because like it was very specifically crafted to do a very specific thing to a very specific control system implementation. And that's it. It was the sniper bullet of OT attacks, because it, highly targeted, designed to affect one particular thing in a very particular way. And not that, those kind of threats don't exist, but the OT space, just the types of devices that are out there and the way they've been implemented, the sort of decisions that have been made in their implementation. And I have all kinds of thoughts about that, which maybe I'll joke about later, because I'm an engineer and I know my people. But you don't have to go out of your way to cause havoc in an OT environment.
Oh, I definitely agree. The example I mentioned with the incorrect packet that was sent to the device and it would erase it, that was not a purposeful attempt to discover vulnerabilities on the device. It was purely one of the steps in our discovery process of interacting with the device and trying to gather information on the device. So we've met up with numerous others that are similar. One device we interacted with, you could send it a totally correct packet for that device. No nefarious aspects of it at all. But if one value was incorrect, in range, but incorrect for what that specific device was expecting, it would crash the device until the device was power cycled. Yeah, exactly.
Yeah, I mean, there's been cases too where just normal operations that you're trying to perform, if you don't perform it in a downtime window, you could possibly halt production for an extended period of time. Like there's controllers out there where if you're just performing a firmware update from one version to another, you could lose your whole program. And, if you didn't save that somewhere, you're dead in the water.
Yep. And again, like we can kind of make a joke about like, oh, well, do you have a backup of that config? And that's one thing if it's like a Cisco switch, but it's, these device configs, can you even back them up sometimes? I mean, hopefully you can, but are you?
Yep.
Well, that also depends on the implementation. Was it a third party that brought it in as a turnkey system, or, have you guys been maintaining it? Maybe there's been a bunch of program changes, undocumented program changes from the initial, stand up of the system to like performance tuning and things of that nature too. So are they doing the good etiquette of making sure that they're backing up those changes as they make those adjustments and all that too? So yeah, and it also kind of rolls into, the IT CIA triad that's out there,
Yeah. Availability, integrity, confidentiality.
Yeah. Well, we say availability first in the OT side, but on the IT side, we usually talk about confidentiality first, right? So that's
Ideally.
Always kind of the big topic out there is, confidentiality, integrity, and then availability. Whereas like we kind of twist that up a little bit on the OT side, saying, well, we're going to do availability, integrity, and then confidentiality because we're more worried about the availability of the system as a whole because it's affecting the real world processes that are out there that are going on. So that's kind of the general dynamic that you're rolling into it. Like these controls engineers, they're wanting to just go out there and buy a device off the internet at large to put it in to solve a particular problem and increase the availability output of their system, right?
Yeah. I mean, that was something that I remember dealing with working in, a controls group for a pipeline company up here in Canada. And they, it was a regulatory thing. Like if they lost, and sometimes it did happen that, radios to the field are not always 100% reliable. And so you lose communications periodically. And that's fine as long as it's a short outage window. But, they actually had like regulatory stipulations that if they didn't have that availability, right? If they lost visibility into what was happening in the pipeline for longer than 15 minutes, they had to shut down. They had to shut the line down. So it's kind of, and there's, other industries under other regulations that impose those similar, often very short time limits on just how long you can have a loss of view situation before you have to assume the worst and bring it all to a halt. So it's easy to see where availability becomes king in that scenario.
Absolutely.
Yeah, I mean, not even on that point, but like Colonial Pipeline was a great example of how even associated systems with OT devices can cause downtime just because you need, like what happened there was that the billing system went down and just through indirect caution, they had to decide to not use a control system right away for that ransomware attack. And, that basically caused downtime and it wasn't even an OT device.
Well, and that's going to be maybe almost another episode entirely because, the way that it's like second order effects, right? You maybe have a security incident on the IT side, but because of legal reasons, regulatory reasons, financial reasons, all of the above reasons, you still have to shut down your OT side. I totally get that. There's a gas plant I used to work at, and it was operated by one particular company, but it had about 5 different companies feeding natural gas into it from their different field extraction operations. And any time that we lost, and again, up in the foothills and mountains of Alberta, not the most reliable communications. Anytime you had a communications outage for longer than however many minutes, we had to start slamming block valves closed because you don't know who is sending you how much product, and you don't know how much product you're shipping out to each person in turn, right? So you don't know how much to charge people. You don't know how much to pay people. That becomes a legal quagmire very, very fast. And I'm sure Colonial was probably looking at something very similar and thinking, geez, like we can't even take this risk.
I think
so that's all a part of those ancillary systems. Sorry, Lance, go ahead.
No, I was going to slightly segue into a different point on the availability. Sometimes it's just technically or mechanically important for that availability of the systems. For instance, like glass factories where you have molten glass running through pipes. What happens if the systems fail there and they stop pumping the glass? All of a sudden the glass starts hardening in those pipes, and now you have to spend millions of dollars to manually remove all of those pipes from the glass factory and then reinstall them because you can't remelt the glass in those pipes.
Yeah. It's like all of a sudden your 5-minute outage became a multi-million-dollar capital project.
Absolutely.
Well, like in food and beverage, which is my main industry of expertise, like in the dairy industry specifically, if you cut the tags on your panel for, like, let's say the pasteurizer, you have to get an inspector from the state to come in and recertify it before you can even operate that equipment again. So, I mean, it could be as simple as just someone randomly cutting a lockout, essentially. It's just a wire tie, but, that causes downtime too. And I mean, people don't even think of that as a threat vector, which is, lack of training.
Yeah, exactly. They're just, I'm just trying to tidy it up a little bit in here. This was messy. Well, yeah, but also that just cost us a lot of money.
Yeah, or you're troubleshooting an issue and, someone's not trained, hey, do not cut that tag. And next thing you know,
yep, exactly.
Got to shut down the equipment.
Yeah, and that comes at cost because, if you ain't producing, then that's just money you are not making. And that that can be, depending on exactly what your industry is, like that can add up to significant cost. If you trip a boiler and it's going to take 36 hours to recycle that boiler, well, that's, the per megawatt hour price of power times what the megawatt output of that boiler is times 36. And you might not make that much in a year, right? Yeah. So, and it's the other thing too that kind of gets me is it's sometimes really easy to, even in the course of like normal operations or balancing between like what's a normal operation and a corporate requirement and maybe even a regulatory requirement, you sometimes come into these situations where you end up causing issues for yourself just by trying to be in line with all of this. It's less of a problem now. More and more control systems are going virtual. More and more control systems are going to high-speed gigabit or more networking. But, even as recently as 10 years ago, and 10 years is a long time in an IT sense, but in an OT sense, it's barely, it's barely starting to mature. Stuff will stay in operation in IT environments for a long, long time. If you installed that system 10 years ago, well, it's probably still there and still doing its job, and it's doing it just quite nicely. Thank you very much. But, I can think of control systems that didn't have a virtual implementation. So they're all on, physical servers, physical workstations, and for which network communications are locked to 100 megabit. Now, for controls traffic, normal operations, that's totally fine. But now what if you have a requirement, whether it's corporate or regulatory, to capture periodic backups? So now you have to situate, a backup server somewhere that can reach all of these network devices, all of these endpoints, and capture full or incremental, or, both, depending on your scheduling, backups of those devices over the same 100 megabit pipe that all your controls traffic is moving. Doing that without stomping on your controls traffic and essentially inadvertently causing yourself an outage, a self-imposed denial of service, can be very, very tricky. And I've seen it happen more than a few times where, I've been in a facility and they're like, well, we have this issue and this alarm set comes up where we start to get like, our primary and secondary servers fall out of sync and we start to like lose bits and pieces of control data. And it always happens on this particular schedule. And then you kind of do some digging and you're like, it happens to exactly align with the schedules that have been defined on the backup server. Well, geez, I wonder.
Yeah, I've had experience in backup and recovery tuning before, and it's interesting to see most of the time when it's implemented, you don't have the correct configurations for the environment, and you got to kind of feel it out, try to play it as safe as possible. But like one good case is SQL database servers. We'll get into the IT side sometime down the road, but like basically that has all your historian data and everything like that associated with your processes that are being used every day for internal and customer facing applications. And, you have to just watch out for these do's and don'ts. Like that's a touchy server to deal with, or like one of the SCADA servers, you got to watch out because the network traffic can just get monstrous.
Man, I'm just over here thinking, it's like, man, 100 megs, that was a luxury back in the day when you were just having like,
I was having
radios,
token ring
radios. Yeah.
I've been having issues even with 10 gig networks, just with the traffic. If you have a large set of applications you have to deal with. So, you have to like stage them correctly and everything.
All that
critical.
aggregation. Yeah.
No.
Oh, yeah. With
sorry, you go, Lance.
Related to that, some of the devices we've researched within the research team here have been probably 90s and 1990s era.
Oh, no surprise. Yeah.
And they've been devices that don't have a network port. So it's just, we're just using the serial port through an Ethernet adapter. So both we have fun bandwidth challenges there, but also we're now connecting devices that have no concept of the internet to a network.
Or so encryption.
Encryption. Yeah, just...
By the way, we're just going to tunnel this serial session over Ethernet, and it'll be fine.
Of course.
And it's like, well, we'll just put some bump in the wire encryption in there. And it's like, well, okay, but like that will introduce, a millisecond of latency, and our process is not even that tolerant of latency.
Mm-hmm.
Oh, okay. How do you deal with that? Geez, I've been in facilities where like you couldn't even use, like you actually, they specifically had to order like those Panasonic Toughbooks that you can still get with the serial port. Mm-hmm. Because certain devices that they needed to connect to, like if you use the USB adapter, just even going through the step of, like the USB, essentially the USB driver was introducing too much communications latency between the laptop and the end device.
Wow. We had a lot of that on the protection relays. You had to buy a very specific chipset out there that would allow that. Otherwise, it did that all day long. It's like you'd be in a protective relay and it just kick you out. You're just sitting there going, what's going on here? And that's when we finally figured out, it's like, there was like specific serial chips that you had to do on those USB adapters because of the conversion process. It's like, wow.
Yep.
Unreal.
So, this goes to show, again, that your average OT environment, yes, if you need, if you are a nation state and you need to very specifically target one specific process, obviously you'll use something finely crafted like Stuxnet, but there's a lot of damage and chaos that can be caused with not even a tenth of the sophistication of that particular piece of malware.
Mm-hmm. And that's kind of the thing. Yeah. It's like across the board, so realistically, and this is kind of what I've seen, over a course of a decade, is like you've got all these IT folks that has, finally gotten up to very varying maturity levels of their security. So they're trying to take these larger security tenets over to the OT side, right? That they've been running for like the last decade, that they just kind of figured out through like the 90s and the 2000s, everything like that. Hell, I went to school in the 2000s, and we still had like a lab that had all public IP addresses on it too. So it's like, who does that these days anymore too? Well, it was fun because, hell, I could connect to a printer up in the computer lab and call up the lab monitors like, hey, can you staple this and deliver this over to Professor Chris and all that? So it was cool back in the day, but like you think about that today and you're just like, wow, that was wide open.
Terrifying.
Commonly nowadays, what you'd find that's similar, in my opinion, is just every OEM that comes into a factory, they have some sort of remote access solution. Now, if you get into the more security mature companies, they normally have a VPN provided and authentication and everything tied into, each contractor with their permissions that they need to have for their devices. But otherwise, you just have a bunch of random VPN servers running on your network. And I mean, that can cause all sorts of issues, especially sorry, Lance.
I was just going to say, hopefully you know about all of the VPN servers that are running on your network.
You might not even know that, or something's running like a cellular backnet. There's all
hey,
sorts.
What's this box?
Oh, that's just the one I play Warcraft on while I'm waiting for the machine to finish.
Right. Oh, well, the prime example, and I think this is one that was going to go out there, is like the whole VPN or cellular and everything like that. You'll go around and be like, hey, what's this box? And nobody knows. And then you eventually find out it's like, oh, yeah, that's the cellular backhaul for the vendor and all that. It's like, well, we didn't know that was even there.
Wow.
Yeah, that's a fun one, too.
And those devices, especially in the industrials, if you don't know about it, it's not getting updated either. And a lot of these devices aren't really built with security in mind because it's coming from a vendor in the space where confidentiality isn't the priority.
Yeah, and that's when you go out and find it on Shodan or something like that, right?
Yeah.
Oops.
Yeah. Well, I mean, it doesn't help too that, like we're seeing it's definitely gotten better over the course of, my time in the industry, specifically in ICS since about 2008. It's definitely gotten better, but it is still very much the case, unfortunately, that, the people who are in the plant and who are at least on the org chart responsible for the system and increasingly for its security, they're not necessarily cybersecurity experts. That's not their training. Maybe they were just a plant electrician before, right?
Yeah.
And honestly, they really just wish they could go back to being the plant electrician, changing out the light bulbs and whatever else. But they did something that kind of got them flagged as, okay, computers. So great. Now you are our NERC-CIP resource. You are our plant OT technical person, whatever the title might actually be, whatever the designation of the role might actually be.
Yeah, you fixed the time on the VCR, so you're it.
Exactly. And Bob the electrician is my, I've met him so many times, right? He's the plant technical contact, but honestly, if you catch him in a private moment, he wishes he could just leave it all behind and go back to, doing electrical work in the plant.
And a lot of times you're doing that on top of
or
work.
that too, right?
So, I mean, the workload you have is just crazy. And that's why a lot of this work has to get farmed out to integrators, machine builders, et cetera, because, the plant engineers are having to deal with a totally separate set of problems. So you have to be a project manager on top of that.
I do want to point out that Bob the electrician, at least the ones that you meet, Ken, are doing something right. They're looking for help. They're talking with people outside the company and recognizing that they can get help. They can contract with others, whatever they need to do to get things done.
Yes. And they're also being supported enough that, they can actually be having those conversations, which, they're usually, at least when I've tended to have those kinds of conversations, they've usually been in the context of, me showing up on site. And not just when I was, not just as a Verve employee, but, past careers as well, past lifetimes as well. I'm showing up because enough people have said yes, that there's budget to bring people in to, either take what's existing and try and do the best you can with it, or implement some sort of security solution, implement some sort of asset discovery solution. They're willing to have the conversations. They're willing to talk about it. They're willing to get that help. And then they have the people who actually control the purse strings willing to listen to them and say, yeah, okay, we can approve some budget for this.
And that's a totally different conversation too. Like when you're walking into a plant and it's like, well, you're not from IT, are you? That's probably a whole episode on its own.
Oh, it is. It is. There's so many stories.
They feel a little better when it's not IT walking in there.
Right.
It definitely helps if you can speak the OT language a little bit. If you can actually communicate an understanding of some of those sensitivities that we've been talking about all episode, right? The fact that you can't just bombard every device with traffic.
Yeah, and I think that's definitely one of the strong things about a lot of us here is that we've been in that spot and we know how to deal with those situations.
I was actually going to say maybe a future podcast could be, how do you have that conversation with management? How can you invite the whatever contractor you select or help get that selection? I think that could be a really good, how to approach your management to pursue better OT security.
Absolutely. That's probably a podcast series in and of itself.
There you go.
Right.
Well, because there's so many different conversations, right? Like, how you have that conversation to, say going from your plant technical contact to your plant manager, like that's one conversation, but then the plant manager going to whatever director needs to actually sign off on the expenditure, that's a different conversation in a different language again.
Absolutely.
Tune into season 2.
Yeah, and they all have different priorities when you talk to each one of them. That's definitely one thing you end up finding out.
Yeah. And then also navigating the discussions about like, well, who's even going to handle that, right? Because different companies have different organizational structures. Sometimes OT is its own thing. Sometimes OT is, essentially a sub-department of IT. And so, well, do we want to bring in outside expertise? Do we just want to use our in-house expertise? And, not that you can't use your in-house expertise, but the rules are very different in IT versus OT. And so, that is something that needs to be, and that's another episode again, is just that needs to be handled very carefully because, man, like, if you just come into the OT environment and try to do it the way you do it on the IT side and apply all the things you would on the IT side, it can get disastrous quickly.
That's why you're quickly seeing OT managed services starting to become a thing too, where IT needs to rely on groups that have that specific experience. And, it's becoming more and more common for places that don't want to build up that internal infrastructure to, rely on having a group bridge that gap for them.
Yeah. Or they just don't have a group that has that conceptually. And I'm sure you guys have run across the same thing as I do. You have these CISOs that are they may be laser focused on patching, across the IT organization. And patching is great across the IT organization because if you reboot a computer there, it's not as impactful as if I'm going to go restart my server that's controlling all my processes in the plant. It's a totally different concept of and how you convey that message out there and the implications of those things too, right? And a lot of them is just knowledge, that knowledge transfer.
Like endpoint protection is a good one where, someone might have a standardized endpoint protection application to deploy, but if you're deploying it in an OT environment and you're not just, if you're doing active protection, you could hamper production with some of the software. So it's just, understanding those nuances.
And even beyond that, in many IT situations, you can just simulate it in a small test lab someplace. Like this is one of our typical installations. This is a typical server. We've spent X number of thousands of dollars on this system, but it's normally in the 5 figures, not 7 figures. And you just can't, in many cases, you just can't afford to build up a full test network unless you're for OT scenarios, unless you have a very large budget. Individual devices we've done research on can take over $1 million for a single device to be set up and configured correctly. So it can be super expensive and you just can't do it to test those patches before you put it in production.
that even presumes that they have a test environment.
Well, right. I mean, I think this was an
Right.
argument saying they probably don't have a test environment. Which
You mean in
makes that-
emulators? I mean, emulators can only do so much.
Absolutely.
You're lucky to even have one on a device.
Yep.
Well, of course, I've got a test environment. It's also called production.
It's that engineering workstation over there.
Right, exactly.
And I think we can do this whole thing in 1 hour of downtime. So don't worry about it.
Oh, man. Yeah, that's another thing entirely.
Yeah, that does happen out there. Well, and it's just kind of the example of those like low bandwidth radios out there. You know, you're trying to do like a firmware update on them or something like that. You know, typically have a spare one in hand out there. So if it does go brick your radio, you can swap it out really quick and all that. But yeah, there's just a lot of moving parts and pieces that kind of go into it, especially the regulatory piece. You know, if you lose visibility out there in a particular systems or regulatory requirements as far as what you need to have on hand when you lose visibility. I know like wastewater, there's DNR things, just like what Ken was talking about earlier, for the components that if you lose visibility on it, you must maintain power at that local facility to be able to maintain, you know, the effluent out from the wastewater facilities.
Yep.
The same thing across the board, multiple different industries as well as different applications out there. So you've got a large regulatory aspect that kind of rolls into it as well that you've got to keep cognizant of. But that ultimately drives all the availability of all of these things all the way around. So they're very cautious when it comes to any type of change out there. I think they kind of coined the phrase of, you know, if it ain't broke, don't fix it type of mentality. And that's the way they operate.
Well, and just to kind of bring it back to that opening example, right? Like Stuxnet was an interesting example too, because fundamentally it was an integrity problem, right? Because the whole idea was that it inserted itself between the centrifuge controller's programming workstation and the centrifuge controller. And it was designed in such a way, if I'm remembering this correctly, it was designed in such a way to basically take whatever the program that was being given to the centrifuges and just kind of scramble it, randomize the commands. Because, you know, when you have a high-speed motor of any kind, whether it's, you know, centrifuge or your car or paper machine, whatever, the usual way you want to run that is you want to just sort of nicely ramp it up to its max RPMs, run it at max RPM for however long you need to do the thing that you're trying to do. In this case, settle out uranium 238 from 235, if I remember correctly, and then ramp it back down. The last thing you want to do is have it like be instant on, then like at half speed, then kind of stop for a second, then shoot back up to half speed, then stop full speed, right? That will get very smoky very quickly.
That's what tuning pump curves comes in.
But that is the point, is that Stuxnet was, you know, designed to basically do this all silently. So the commands that the operator put in were not the commands, at least not in the same order, that reached the centrifuge. But then what was coming back to the operator was also not what was actually happening, right? So it becomes an integrity issue. But I mean, you know, that only works because you're maintaining that appearance of the data availability. You're maintaining the appearance of view and of control and of normal operations, which is still it is that king in just about any OT environment. You need to maintain that availability. And hopefully the data you're getting back is good. And if it isn't, that's another problem that you have to address. But if you're not getting it in the first place, that's the show.
Yeah. Two totally different aspects there, because you want the availability of the data, but the integrity of the data, because it's also probably driving regulatory decisions out there too. So like in a emissions monitoring environment, you know, that's some regulatory components that you've got to go out there. So you got to be extremely sure of that data too, right?
That, you know, and that's another episode in and of itself. Is SEMS critical infrastructure? Should we be considering SEMS critical infrastructure? Because in a lot of the engagements I've had over the years, continuous emissions monitoring is, well, it's a thing. And, you know, like we'll kind of take it into account, but we don't really it's not necessarily under the, you know, the facility
under the radar.
Exactly. Yeah. It's not usually like on the radar for like, oh, well, this is part of our NERC compliance. That's a critical asset over there. Really. So if you lose that, how long can you operate without emissions monitoring?
Exactly.
What does the law say?
Mm-hmm. So, I mean, it's under the regulatory purview, right? So, I mean, you've got certain permitting limits that you can go up to. So if you lose visibility into what your output is for your permitting limits, well, guess what? I got to shut down until we figure this out over here. So, yeah.
But it's not a critical asset.
Right. Yeah. I know it kind of varies from state to state and all that stuff too. So, but it probably needs to be under purview because, and I just had this same conversation the other day, and it's just like, well, you guys do have this out here and you do have this monitoring capability, but it does have impact. And I think that's what it really comes down to when you're going through like the risk assessment and things of that nature is, what is facilitating impact to your processes and how does it equate out monetarily for your systems? Like if I'm not able to produce electricity because my emissions monitoring gone down, well, it's pretty impactful,
Yep. But yeah, that's also now, that's another episode, but it's also, that gets back to Bob the electrician, right? Now you're expanding his scope yet again, and he's already kind of tapped out and he doesn't understand anything of what you just said anyways. So what do?
I think the summary is
go to again.
Yeah. Bob, it's okay to ask for help.
Yes, it is absolutely okay to ask for help. Please. Well, we're coming up on the hour mark, and that seems like a good opportunity to bring it to a close. But just kind of goes to show, like, why does this stuff matter? Well, whether it's power or food or wastewater or paper or whatever, OT is hooked up to a lot of stuff that is really, really essential for the smooth and orderly operation of everyday life in, wherever you happen to be. Things get really bad really fast if you don't have power and if you don't have water and if food production falls off. These things become problems and very quickly. And it's a challenge because OT is also very fragile, or it can be. It's the devices that exist within these environments, which are often hooked up to critical processes, are not necessarily as robust. Maybe environmentally hardened, right? They can stand up to a torrent of ash or dust or whatever. But from an electronic standpoint, they're fragile. They tip over easily. They get the wrong kind of traffic, and they can delete their whole config. There's solar flares. There's regulatory requirements. There's all manner of things that make the successful operation in anything resembling a secure manner of an OT environment very, very challenging. And maybe that is the best takeaway is that, it's okay to recognize that you can ask for help and that you probably need to ask for help. And it's okay to ask for help and for budget because the bottom line looks a lot better when the power plant stays on, when the milk pasteurizer stays on, when the paper machine keeps running. The bottom line looks a lot better when those things happen. And if even something inadvertent causes disruptions, the bottom line looks a lot worse. That was my closing thoughts. So Lance, any other closing thoughts from you?
I think you summarized really well. Obviously, as you mentioned, there's all sorts of crazy failure modes for these devices once you start connecting to them to the network, but we need to get them on the networks for the data you get out of them. But so it's a very unique challenge set. Yeah.
How about you, Tyler?
Yeah, it's the same thing. It's all about the monitoring and kind of knowing what you have out there. And I think that's kind of the major tenets that we've also realistically see across the board is knowing what you've got out there. That's, across multiple different cybersecurity frameworks. That's like first steppers is knowing what you got out there. The other component is, being able to kind of effectively monitor those systems for things and doing backups, things of that nature. So it's a lot of the same tenets from the IT world that we're just trying to apply on OT, but you've got certain different boundaries that you have to abide by then when you're trying to apply those tenets. So it is an interesting venture, and I think there's plenty of people to help out there, especially at Verve. We can definitely help you out with those aspects and get you going there.
And Dylan, any last thoughts?
Yeah, it was an honor and privilege to be on this first episode here and really enjoyed the talk. I feel like there's a lot of knowledgeable people out there and there's a lot of knowledge to be shared. And, I'm just looking forward to seeing what we can share with the world here. And, there's a lot of things to talk about that don't get talked about. Like a lot of the times you can go into Stuxnet or WannaCry or NotPetya or any kind of attack, but like the number one thing is just being able to understand what's going on and just starting out with those first baby steps that a lot of places have to get to. And I feel like that's the most important part. People shouldn't be focusing on step 3 or 4 when they aren't even at step 1 yet. So I feel like this was a good talk.
Brilliant. Well, thank you all for taking part in the pilot episode, and thank you out there to anybody who listens. Until next time, this has been OT After Hours, a podcast about industrial cybersecurity because it does matter, and we would like to help you get through those challenges.